This lesson is more on inverses. We're going to kind of be combining some sum and difference formulas with inverses and going from there. So this looks a little bit scary. It's really not too bad, okay? This first part right here, again, is an inverse, so it's asking us to figure out cosine at some spot on the unit circle. I'm going to call it alpha because you can see that I have two things going on in this problem. So cosine at some spot on the unit circle is 1/2. And the question is, I wonder what that spot is. Okay, I don't know what that spot is. I know the cosine value at that spot, but I don't know what angle it is. So that's not doing me a whole lot of good right now. This is asking me to figure out sine at some other spot on the unit circle. I'm going to call it angle beta. So sine at angle beta is 3/5. And again, when you're doing inverses, the question is always, what spot does that happen at? What angle is that? Okay? I don't know what angles those are right now. But in the end, my ultimate goal is to be able to figure out sine at this angle right here, which we called alpha, plus this angle right here, which we called beta. And that's what I need to do. Okay? And again, you're not going to distribute when you see something like this. You are going to use your sum and difference formulas. So if you look at your sum and difference formulas, you will use this one right here because I am doing sine at alpha plus beta. So I'm copying that from my master formula sheet. Sine at alpha, cosine at beta, plus cosine at alpha, sine at beta. All right, now the problem is I'm not going to have every piece of information that I need. I have cosine at alpha right here, so I can plug that in if I want. So I can find that by doing 1/2. I have sine at beta right here. That's 3/5. But I don't know sine at alpha and I don't know cosine at beta. And so I'm going to need to be able to figure those out somehow. So I am going to first of all start with angle alpha, and this is where your inverses comes in. Notice that cosine at angle alpha is positive 1/2. If you use your restricted intervals, cosine is restricted to between 0 and pi, which of course between 0 and pi is the upper quadrants, okay? Well, in quadrant 1, your cosine value is positive because it's your x value, and quadrant 2, your cosine value is negative. So because this is a positive 1/2, I know that cosine has to be in quadrant 1, okay? So when you draw your triangle here, there's your angle. I'm going to call it alpha. Okay, there's angle alpha. Cosine is my x value or my adjacent over my hypotenuse or my r, which will be 2. And then if you do a squared plus b squared equals c squared, this will come out to be positive root 3 because you're going up to get there. So you're in quadrant 1, so it will be positive root 3. Okay, so now I can fill in this piece right here. Sine at alpha is my opposite over my hypotenuse at alpha, or my y over my r. So that will be root 3 over 2. And now I need to use angle beta to figure out the next piece. So my beta is in blue. So I'm going to go over here and I'm going to figure out beta. And what I know that sine at beta is 3/5. Okay, so I'm going to use my restricted intervals. And sine right here can be restricted to between negative pi over 2 and positive pi over 2, so between here and here. Sine is your y value. Remember, your y's are positive in 1 and negative in 2. So because this has a positive 3/5 sine value, I know for sure that I'm working in quadrant 1. Okay, so I'm in quadrant 1. Sine, this is angle beta right here. Sine is your opposite or your y value over your hypotenuse. So this will be 3, this will be 5, and then of course you can do a squared plus b squared equals c squared, and this, your adjacent or your x value, will be 4. Okay, positive 4 because you're in quadrant 1. So now when I go back up here, I can fill cosine at beta in. Cosine at beta is my x over my r, which of course is 4/5. Okay, so now all you need to do is simplify, which you can do no problem. When you multiply fractions, remember, you do not need common denominators, so I can just multiply that and get 4 root 3 over this and get 10. And then across the top, 3 times 1 is 3, and 2 times 5 is 10. And because I've got common denominators, and I want you to do this anyways, your common denominator is 10, and then you can just put 4 root 3 plus 3. Can't simplify that any more than that. Okay, so there we go there. All right, similar problem here. Again, this piece is asking me to figure out cosine at some angle, which I'm not sure what it was, is 3/4. Okay. And this is asking me to figure out sine at some other angle is 0. And the question is, I wonder what that angle is. Okay. Doesn't really matter because ultimately what I have to be able to do is find secant at this angle right here, wherever that was, angle alpha, plus this angle right here, which of course is beta, and that's what I need to figure out. Okay? So, I don't have a formula for secant at alpha plus beta, so remember that secant is the reciprocal to cosine, and so I will use this formula right here under 1, so 1 over that. Oops, wrong way. So 1 over cosine alpha cosine beta minus sine alpha sine beta. Okay. So some of this I can plug in. Like I already know what cosine at alpha is. It told me that at the beginning. And cosine at alpha was 3/4, of course. Oops, I have 1 over this mess. Sorry, that got a little bit messy here. I might try to slide this down for you. There we go. All right. Cosine at alpha was 3/4. And sine at beta is 0. Okay? But the rest of it I don't have enough information. So, again, I'm going to use the red angle and use that for alpha. Cosine, again, is positive 3/4. Cosine is restricted to 1 or 2. And because it's positive, I know I'm in quadrant 1. And so when I draw my triangle, cosine is adjacent over hypotenuse. And then you can do a squared plus b squared equals c squared, and you will get √7 right there. Okay? I assume you can do that piece of it. All right. So now I can plug in sine at alpha. So sine at alpha is your y value over your r value, and that will be √7 over 4, or opposite over hypotenuse, if you want to think of it that way. Okay, then I still don't know what cosine at beta is. And so at the beginning, it told me that sine at angle beta was 0. Okay, sine at angle beta was 0. Well, think about sine being your y value. The only place on your unit circle where your y values are 0 are here and here. And sine is restricted. If you look at your restricted intervals, sine is restricted between here and here. And so this one works and this one does not. Okay, so I can't really draw a triangle, but I know I'm over here actually, and my coordinates over there are 1 and 0. Okay, so cosine at beta is your x value at that spot, and so I know I'm at 0 degrees. And your x value at 0 degrees, or your cosine value at that angle, is 1. Okay, so now all I have to do is simplify this. A lot of people forget that you have this whole contraption underneath the 1, so be careful about that. 3/4 times 1, of course, is just 3/4. And then -7/4 times 0, of course, is just 0, so I don't need that. And 1 divided by 3/4, if I flip that, will give me 4/3. So that's that. Okay, and the last one. Again, that inner piece is asking you to figure out sine at some spot on the unit circle, and I don't know what spot that is. I could call it alpha, beta, theta. It doesn't really matter. I'm going to call it theta. So sine at some spot on the unit circle is 3/5. And this is the question. And I can draw this triangle and I can figure it out. Okay, so I'm going to go and I'm going to do that. Sine is positive. Sine, of course, is restricted to between -π/2 and +π/2, so I'm restricted over here. Sine's your y value, which is positive in quadrant 1 and negative in quadrant 2. So I know for sure that I am in quadrant 1 because it's positive. So when I draw my triangle, I can draw it. Sine is my y, or my opposite, over my hypotenuse, or my r. Okay. when you do a squared plus b squared equals c squared, this will come out to be 4. All right. And so now, here's the deal. I can tell you what sine is at that spot. I can tell you what cosine is at that spot. I can tell you what tangent and secant and cosecant and cotangent are at that spot. I still can't tell you what that angle is, though. I don't know how many degrees theta is. All I know is it's somewhere between 0 and 90, but I don't know how many degrees it is. Okay? What I can tell you, though, is that ultimately what I have to do is I have to find cosine of 2 times whatever spot that happened to be at. I still don't know the spot. But I have to find cosine 2 at that spot. So now you're going to use your double angle formulas. And cosine 2 theta, you can use any one of those. It doesn't matter which. I like the top one. I like cosine squared minus sine squared. So that's what I'm going to use, but you're going to get the same answer no matter what you do. So cosine squared at that spot minus sine squared at that spot. Okay. So my cosine at that spot is my x, or my adjacent over at my hypotenuse, or my r. So cosine at that spot will be 4/5. Sine, of course, is your y value. So that's 3/5. Okay? And then 4/5 squared is 16/25 minus 3/5, which is 9/25. 16/25 minus 9/25 makes 7/25. And that will do it for us. We will see you next time.